Thank you, Anita. I just want to thank you, organizer, for inviting me. I'm thrilled to attend the workshop. I feel that I've already learned a lot. I learned from the colleagues from around the world who are actually working in this area, which I think I just jumped in this area like a couple of years ago. So I'm going to present a paper that we published last year in Translation Research Series with my student. It's about applying ethical principles in transit design. This is a joint work with two of my PhD students, Tianxin Dai, he's in the audience, and also Jiayang Li. So let's get started. So let's talk about the philosophy first. So I would argue the prevailing design philosophy in transit is about basic trade-off between mobility and efficiency, right? So mobility is about travel time and speed, and efficiency is about labor, fuel, subsidies. Okay, so the idea is that you try to maximize mobility as a minimum at the minimum possible cost. Okay, so that's one component of the philosophy. The other component of the philosophy is that we try to target average user, right? So which means implicitly this means everybody is treated equally. Okay. Of course, this philosophy has been criticized. We have heard a lot yesterday. We continue to hear it today. The first problem has to do with the focus on mobility, right? Many critics had pointed out that mobility is not an end in itself. It is a means to something else, right? So we travel not for the sake of travel itself. We travel in order to access goods, service, and activities. Transportation or mobility is for the purpose of accessibility, right? So in this study, we define accessibility as the extent to which land use and transport system enable individuals to reach activities and destinations by means of transportation modes, right? That's how we're gonna define success in our design. So that's accessible. That's what I mean by accessibility based. Now, another problem is that most real people are not average, right? So the target on average person is a problem. In transit, famously, we have this dichotomy between captive users and choice users, right? The choice users are those who are wealthy, who have options. You could only persuade them to use transit if you can provide a very good service. Whereas the captive users are people who don't have a choice. They have to use the transit. They're captivated. Believe it or not, there's actually a segment of users.
Question. Yeah, and maybe you go on before I challenge that.
Okay. There is actually a segment of people who are captive by choice, meaning you actually have money to buy a car, but you decide not to. So you're captive by choice. Of course, go ahead.
Yes, I just want to say, I think it's highly problematic that we consider captive users as captive users. They actually have a surprising range of choices, which are in many cases even worse than transit, but it's a choice. So they walk a lot.
True.
They ask for rides a lot, and they just forgo trips a lot. And by presenting them as captive riders, it seems that we do not have to care about the service we provide to them. And so I've been looking for a better term. I didn't find it, but captive users is a fundamentally flawed term that binds our thinking about them.
Thanks. Yeah, that's a term that is being used a lot in the American literature.
No, for decades.
For decades, that's right. In fact, I think there's, in terms of the design target objective, there has been this debate among transit agencies who we really should target, right? Transit has had a very broad range of mandates, right? So you want to serve, you want to provide a basic level of mobility, but you also want to decongest the roads, you also want to improve sustainability, you want to reduce emission. If you want those more, grandier objectives, you really want to persuade the choice users to switch from driving to transit. But if you allocate your resources to target them, focus on them, then you're probably going to ignore the captive users. So there's a lot of debate about which one we should really focus, right? Now, I just want to say that of the captive users, there's also this subset, I would argue, there are vulnerable populations. And these people are going to be left behind because you're focused on average users. The philosophy is on average user. They're going to be left behind because by definition, they're not average, right? They're below average, okay? So there are a lot of disparities in transportation supply in the United States, right? This is well established. It is well known that the poor and low income, by the way, poor and low income are different concepts, right? Low income, I think US is 80% of the median income. Poor is, there's a poverty line. If you're below that, you're poor. But both groups they're much more likely to use transit regularly compared to others, right? Another fact is that the racial minorities are severely overrepresented in the transit commuters, right? And also, despite that they are overrepresented in the transit commuters, they are more likely to live in areas with poor access to transit. So this is a clear disparity, right? Now, these people also, they have to bear, because they're low income, they have to spend a much higher share of their income on transportation than other groups. If you look at the data, the lowest 20% of the population in terms of income, they spend almost 40% of their income on transportation, which is a staggering number, right? Now, if you look at the richest 20%, they spend about 11%. This is so there's a huge discrepancy in terms of the wealth distribution as well as the access to transportation. Now, I'm sure everybody, probably vast majority of you have seen this, right? So this one explains what's the difference between equality and equity, right? And explains very nicely why if we treat everybody equally, it can be really unfair, right? If you give everybody a box, guess what? Somebody end up not being able to stay the game, right? So that sounds very unfair. Equity, therefore, implies that you have to somehow give a preferential treatment to the disadvantaged group. In this case, the shortest kid. The shortest kid here is clearly the most disadvantaged group, and therefore you should treat them differently. Okay, that's the idea. So average design cannot be fair. Now we're talking about the fairness, and fairness is a kind of a loaded word. What do we mean by fairness? Is it treating everybody the same way fair, or is it preferential treatment of the disadvantaged fair? Right? This is a metaphysical question, and it probably requires some kind of value judgment, and we have to render a value judgment, right? As engineer, I think 5 years ago, I would be really reluctant to render any value judgment. I feel I'm not qualified to do that. I feel that we should really leave this question to politicians and philosophers, right? But now if you think about it, whenever we do design, we prescribe. Whenever you prescribe, you have to render value judgment. So value judgment is always there. It's always there, right? It's just, except that we choose to ignore it. The value judgment we have been using for a very long time has been utilitarianism, right? And utilitarian, according to this school of thought, justice is achieved by maximizing the total utility for all groups. That also means you're maximizing the average utility or the utility of the average person. Okay, so. That right there, you're rendering a value judgment. There's a different group of thinking, or we have heard from Karen and other people about egalitarianism. I came to know John Rawls' work only, 3 years ago, perhaps. I read a book 2 years ago. So I'm sure I didn't understand the book fully. I missed a lot, but I just want to share with you what I thought. What is a theory of justice? John Rawls' theory is called justice as a fairness, right? So what I think the key proposition of his book is centered around these two principles. Actually, he has 3 principles. The first principle is irrelevant because it's about the liberty. Everybody should have maximum liberty. We can all agree to that. But the second and third principle that he proposed was about what kind of social and economic inequalities are tolerable. What kind of equality we should tolerate as a society. And basically what he said is that this kind of inequality are just. That means we should tolerate it, if and only if A, they are attached to positional goods, open to all under condition of equal opportunity. the positional goods is a term I invented, or I borrow from some others. This is goods. This is access to offices and positions. Okay, so I always thought admission to Ivy League college is kind of positional goods, right? So those kind of goods should be open to all, but under condition of equal opportunity. So I would call it equal opportunity clause. But B is that we should maximize primary goods enjoyed by the least advantaged member of society. And John Rawls called it the difference principle. Okay, so what are the primary goods? I think his book didn't mention, but when I read Carroll's paper, I think you published in 2012, and I think you argue that transportation and accessibility should be considered a primary good. So therefore, we should apply the difference principle. Okay, difference principle would be applicable if you believe John Rawls' theory of justice as fairness. So that would be one of my focus. So I'm going to try to apply the difference principle. I will try to compare the difference principle with the utilitarianism principle. Now, in the United States, the U.S. government has been promoting equity as a desirable outcome of society since, I would argue, since 1960s with the passing of the Civil Rights Act, 1965. But in 1994, the Clinton administration issued the executive order for environmental justice, right? So this is what they provide general guidelines for EJ, and they requires that distribution of benefits and impact to be equitable. Requires that no one community should bear a disproportionate burden of any adverse impact. So this is 1994, but 3 years ago, after Biden took office, he issued another executive order. This one is really on equity, right? In this time, the terminology is on equity, and so the order basically proposed a comprehensive approach to advancing equity for all, and focus on the improvement of the historically underserved communities. It includes, among other actions, such things like allocating federal resources to advance fairness and opportunity, promoting equitable delivery of government benefits and equitable opportunities. Now, transit in the United States has been, since 1960s, subsidized heavily by federal government, okay? So under these clauses, transit design should be subject to the provisions of the equity executive order. But that's not really what happened, what has been the case in the field, nor did these orders specify how we should implement these general guidelines in the actual design, okay? So what is the practice? Here's my understanding. I mean, the audience, if you know better, you can correct me. I think in order to comply with this guidance, the planning agencies in the United States, metropolitan planning agencies, they have been conduct so-called equity analysis as part of their planning process. The idea is that you want to make sure whenever you're implementing some changes, okay, you're building a project, you want to make sure no harm is done, okay? The vulnerable population, they are not have a greater burden than other population. So essentially, the distributive effects, they are a byproduct of design. So you're not really making design targeting equity, right? You're making a design, but then after you have done the design, you perform equity analysis to make sure everything's fine. We're not harming anybody. So that's really, equity really is not objective, right? So I would say that I would argue that the actual design I still informed by price, not by the values. Okay, so the real gap I think is I can summarize it using the quote, is to say that economists, they know the price of everything, but they know value of nothing, right? I think this here the straw man is economist. I guess engineers would bear the same blame. So after I read the book and all that, I realized that we really should, moving forward, as engineers, we should really be willing and able to incorporate values with price, right? So we should try to do something about it. We should really think more about incorporating value into the engineering design. So that's really what brought me into this type of research. Okay, so what are my research questions in this particular study? So we were thinking, okay, now we realize that we should do something about it. How do we apply other ethical principles in transit design, maybe design in general, right? Another question I was very interesting. I don't know if it's the right question. I guess I can hear something. I would like to have your feedback. My question is, can we price values, right? Can we price a value like equity? Should we go and price a value like equity? And should there be a limit on equity? Okay, if there should be a limit on equity, how should we find it? Okay, so that's my questions when I start this inquiry. So what is my approach to answering those questions? We will develop a very simple model, a very highly stylized corridor transit design model, and we'll try to optimize accessibility, and we'll try different ethical principles. But we will, after we finish design, we'll then measure equality based on Gini coefficient, and we'll see how different design actually lead to different equity results.
Michael, I have
Yes.
a question. In your previous slide, you basically said, well, the transportation agency tried to do no harm. But what was not mentioned in the comment is the role of politics. In the sense
True.
that basically, transportation agencies are not, let's say, operating a vacuum. And basically, what's the role of politics?
It is politics. What I think we can contribute as engineers is to inform the debate and discussion of politicians. Right? When they debate, I think we can. What we can do is to help shape their discussions, right? So if everybody is talking about, oh, we would like to have this and that value in our design principles, I guess we can tell them what will be the consequences, right? And that would help them, help the discussion. That's my hope. Does that make sense? Okay. All right, so let me just go into the model. It will be a very simple model, okay? So we have a linear city. This is a black line. So travelers just live on this linear city, and therefore they will be served by a bus service, okay? So travelers can either they can either walk or they have to take a transit. They have no cars. Everybody use transit, okay? Now, the opportunities, this is a distribution of the opportunities. I use F to denote the distribution. Okay, so this is a bell curve that I show here, but it does not have to be a bell curve. It can be any distribution really. It doesn't even have to be continuous, right? So now, if a person you live here, imagine you live here, you can obviously walk this way to the left. You can walk to your right, right? And therefore, you will be able to, within a certain time budget, you will be able to cover a certain distance, and that will give you access to the opportunities, and we will be able to count how many opportunities you actually have access to, and that will be used as a measure of accessibility. That's what we do. And the transit agency would be designing a bus service along the corridor, right, to serve the travelers. So that's a basic setup. There will be a budget fixed at capital B. So we have the demand is uniformly distributed. Traveler, I have said that, and travelers have the same travel time budget. We denote that as lowercase letter b. Now, for any equality analysis, you have to differentiate travelers, right? You have to find a way to group people. So here we choose to group people based on their home location. So where you live, differentiate, give you identity. Okay, and there is a natural disadvantage for those who live at the edge of the city. The reason being, if you live on the edge of a city, there's only one way you can go by transit. Karen?
I think one thing that helps, you made that case at the beginning that it's hard to get people to think about distributional equity. But using a term like disadvantaged, in fact, let's flip it, right? People were more advantaged and more likely to live in the center,
Cool.
right? If you think about redlining and the way mortgages and all the systemic
Absolutely.
historic equity in the U.S., flip it. It's not, and I think that gets people to think about it. It isn't that we're trying to give a leg up to people who are disadvantaged. It's that we gave so much of a leg up to so many people for so long that they get it. So it's the same model, but just framing the way it's worded.
Thank you.
Kind of shines.
I think about that.
Yeah.
That's a good point. Now, I have already said that if you're located on the periphery, you're naturally disadvantaged because you can only go one way to use transit. If you go outside, you go out of city, there will be no transit service, right? So you're naturally disadvantaged in that sense. Another disadvantage comes with your location. If you're located in a place where F is small, you are naturally disadvantaged, right? Because if you travel the same distance, you cover less of opportunities. So these are the two disadvantages, right? Now, let me talk about the supply of the transit. We consider two cases. In the first case is homogeneous supply. Very simple. You only have two design parameters. You have headway, you have so-called stop spacing, and the trade-off between the headway and S will determine the transit design. So once you decide H and S, you can then decide for the time budget that you're given, B, how much you can travel by walking. Easy, right? Just walking speed times the budget. For the transit, it's slightly more complicated because you have to consider access time, right? You have to consider waiting time. You have to consider the lost time per stop because bus, every time it stops, it will lose some time. So we count for those design features, but still it's a very simple model, right? So if you take transit, this is how much you will be able to travel for the given time budget, small b. If you walk, this is how much. Now, we also design a heterogeneous transit design model. And in this case, we have three rather than one service. We have also the corridor service. But now in order to differentiate, we create a central service with its own unique headway, we call HC. We also run a periphery service, which we call its headway is HP. So now we also have the D, like that determine the length of the central service, right? So now we have 5 design parameters rather than 2, right? Previously we only have H and S. Now we have H and S, HC, HP, and D, 5. Okay. Now we can similarly calculate the budget travel distance for the transit. It's a slightly more complicated concept because now if you think about if you're living here, if you live here and if your destination is within the same zone, you are going to have access to both lines, right? This will cut your waiting time. That is benefit, right? However, if your destination goes beyond, goes across the boundary, now you have to think you need to transfer, right? Because you have, if you happen to be on this line and now your destination is on the other side, you're gonna have to transfer. So in that case, taking advantage of both services is not gonna help you, okay? Rather, you would, if your destination is outside of your own zone, you're gonna just take the corridor service, okay? And how likely you're gonna take either service depending on your location, depending on how far away you're from the boundary, okay? And now, we don't need to get into the details, but those equations basically take care of those considerations, okay? If you're start from here, you're going to, depending on your destination, depending on how likely your destination will go out of your zone, we take an average here of your waiting time, basically, all right? So that is the physics behind the heterogeneous supply. This is very important because I believe the trade-off ultimately is reflected in how we set up these trade-offs. So I think it's important for everybody to understand what is the physics that is involved here. Now, let me talk about accessibility. We define accessibility based on so-called accessibility opportunity, the opportunity sphere. This is a very, sounds like a fancy term, but it's really not. It's just it's just the how far away you can go to the left, how far away you can go to the right, and that's a boundary, right? And then you use a boundary to and you integrate the opportunity that you will be able to access, and that will give you the total opportunity. The only complication is when in the case of transit, there is a boundary, right? So there is a chance that your boundary can be cut off. If you take transit, your boundary will be cut off at the edge of the city. Okay, so that's the only complication. So let me give you two examples. One is here, resident A. Okay, in this case, you can go left or right, and so this is your so-called opportunity sphere. And now this is a sphere. Now, if you are living very close to the edge of the city, when you go to the right, you will have to walk. You will decide walking is better, because walking can actually can allow you to go further than take transit, because transit basically stop at the edge of the city. Okay, so in this case, your sphere is to the left is LT, to the right it becomes LW. So there is some kind of switching here. So that makes the model more complicated. Anyway, so once you have the sphere, in order to get accessibility, you just do the integration. Very simple, right? You just do the integration. That will give you A. That's what we call accessibility. Okay. Now let me talk about ethical principles. There's
Quick question.
Yes.
Your sphere, is that based on distance?
Based on distance.
Not on time.
Everybody has the same amount of time budget. Just like
Yeah, but I mean, if you have a faster mode, you're gonna catch more opportunity.
True. So you're gonna go far. You're gonna go further.
Yes, but if the measure is based on distance, then you're not sensitive to different modes of transit, I guess, that you might be providing.
You mean if you have like a different mode of transportation?
Even with transit, you have services with, more frequent headways and so on, and those with more stops or less stops potentially. So your accessible opportunities are going to vary depending on.
It does. So because the LT, if you go back to say this one, LT is actually depends on the service design. So that means the LT is actually a function of design. Okay, sure. So we talk about utilitarianism, right? That's maximize total accessibility. This will involve you do another integration from one edge of the city to the other edge, right? Total accessibility. There are different egalitarianism principles. There's sufficient principle, right? Minimize cost, but ensure everyone has a floor. Everyone's accessibility has a floor. There's maxi-max principle that Carol proposed. That is to make sure that the maximum accessibility gap be no more than a threshold. So you can have the highest and lowest, but then the difference between the two cannot be larger than a certain threshold. And there's, of course, John Rawls difference principle. Okay, everybody knows this, so I can skip that. If you look at the model, I will first present the homogeneous supply model. So you would define the total utility. This is the integration of accessibility, but you can also define the minimum of the accessibility. Okay. The design problem is very simple. Okay. We have a budget constraint. We have a lower bound and service constraint. This is a very loose constraint. It's not very active. So really, what we really have is just the budget constraint. Sufficient principle. The idea is that you want to minimize the cost. subject to the lower bound, right? For the maximax, it's very similar to utilitarian principle, but you would have additional constraint which says the maximum accessibility and less the minimum accessibility should be no more than certain threshold. Difference principle, very simple. It's identical to utilitarian principle except the object function is a mean. Okay, Now I want to give you analytical results. I don't know if you find this surprising, but when I first figured this out, I thought it was kind of surprising, which is in the case of a homogeneous supply, it doesn't matter which principle you use, really. You should just maximize mobility. Maximize the distance that you can reach by transit. That will maximize the total utility, total accessibility, but also maximize the minimum accessibility. Perhaps it's not as surprising. Okay. So essentially, what I'm saying, if you want to have a difference, you really have to do heterogeneous design. You have to differentiate in your supply. You have to somehow discriminate somewhere. Okay. So if you look at if you want a visual illustration, okay, so this is Y here is the headway, this is a station spacing, and this would be the budget constraint, right? So this is the indifference curve, and so if you have a lower budget, this curve is going to move up, right? And this curve is the budget travel distance curve. This is how the two variables is related to the budget travel distance. Basically, when these two curves cut each other, that's your optimal solution, right? So very simple. We just make two observations without proof, but basically, when you have a sufficient principle, which means you have a lower bound on this this curve, what you do is really you just instead of sliding this curve, you are sliding the budget curve. So you are sliding budget curve up and down, and it will touch. That will be your optimal solution. So basically, what we're saying is that if you set the threshold at a proper value, then the sufficient principle and other principles are essentially the same. I guess the same can be said about maximax. I think I'm going to escape in the interest of time. For the heterogeneous transit design, the idea is the same, except that now the sphere function becomes much more complicated. It's just more complicated. It's not complex. It's just Tianxin had done all this dirty work to figure it out. It's very hard because you have all these boundaries. You have to go through this threshold and you have to change. Very complicated. So that when the x is different, the functional form is going to change. That's a problem. So when you do the integration, the lower bound and upper bound is actually changing with x. Not only the function itself changing with x, the bounds are changing with x. So it's very hard to do the integration, very hard. But anyway, that's a technical detail. But then you can, here I'm going to drop the maximax and sufficient. I will focus on utilitarian and difference. And you can see again, the model is very simple. The focus here really is on the budget. There's a budget constraint, right? And you can see there's H, S, HP, and HC. These are the transit design parameters. I just want to say this model is very hard to analyze, so we don't really have any analytical results, but we can see that if you think about it, utilitarian principle is going to give high priority to places where the opportunity density is high, right? So if you are utilitarian, you're going to focus on the places where the concentration opportunity is very high. That's what you're going to do because that's most efficient. And you would also focus on the central area. You're going to stay away from periphery because periphery is hopeless. You don't want to. It's not going to help you. But we surmise that the difference principle is going to do exactly the opposite. Just how much? That's what we're interested in to find out. Okay. This is a very small model. Solving the model itself is really not that challenging, but it can involve It can be complex. I mean, Tianxian can tell you how much he has spent time on trying to solve this seemingly very, very simple model. We actually had to do a lot of numerical experiments in order to find the solutions. So I think I'm going to skip this because I don't think these are the main points. If you're interested, if you find solving these models challenging, I'll be happy to talk to you about them. Let me just go right to the numerical experiments, and I'm sure everybody wants to see the results. So we try two different distributions, right? We try uniform distribution. That means the opportunities everywhere is the same. So in this case, the only disadvantage comes from the fact that you live at the edge of the city, okay? We also try a very heavily concentrated distribution. We use a Cauchy distribution. So in that case, you will have a very strong peak. So those who live in the center will have a very big disadvantage, right? So we focus on these two extremes to just contrast what kind of results we can get out of these very extreme cases. So these are the parameters. We have a very long corridor, 40 kilometer, and our budget travel time is 30 minutes. We're gonna perform a sensitivity on this budget travel time. I think the other numbers are not important. Let's look at the homogeneous case first. We find out optimal solution for our numbers. So the number is headway is about 15 minutes. The stop spacing is about 460 meters. We found that transit obviously improved accessibility everywhere. Okay, so let me just jump here. So if you look at here, this is for the uniform distribution results. Okay, now y-axis here is accessibility. X is location. Okay, so the blue line representing the accessibility when there is no transit service. In this case, everybody walks, right? Everybody walks, so it's a straight line. Everybody has, this is a perfect equality, okay? Now, after you have transit, everybody's accessibility goes up. That's understandable. But there's inequality, and the inequality happens on the edge of the city. As I said, because those people who live on the edge, they can only use transit when they go toward the center of the city. They cannot use transit when they leave the city. Therefore, they are disadvantaged. So if you look at the Gini coefficient, in this case, is very low, okay? When there's no transit, Gini coefficient is 0. When you have transit, there's some inequality, but it's still very small, 0.04, okay, very small. Now, how about the other distribution when you have a very strong peak in the center of the city? In this case, you can see even when everybody has to walk, there is very large inequality, okay? When you have transit, this line obviously push up significantly. Everybody enjoy, but of course, interestingly, in this case, the Gini coefficient doesn't really change much, right? So if you look at here, it's almost identical. So after you implement transit, the inequality doesn't change, okay? So that's for homogeneous case. Heterogeneous supply is much more interesting, okay? So let's look at the result here. I'm presenting, this is uniform distribution, this is Cauchy distribution, and utilitarian, egalitarian, okay? I'm giving your the design parameters, okay? So this is the headway of the corridor, this is the headway of the periphery, this is the headway of the central, and these numbers are given in hours, okay? Now, so if you look at here, first I want you to focus on utilitarian, and you can see utilitarian gave a headway of 50 hours to the periphery. This means actually the design prefer not giving any special treatment to the periphery, okay? The utilitarian does provide a service in central, not very good service, right? You see the headway is 1.5 hours. In the case of uniform, in the case of Cauchy, the central service is much better, but still not great, okay? So that's utilitarian. Now, what about egalitarian, the difference principle? you can see the priority is reversed as you would expect. But interestingly, you can see in order to reverse the inequality that is actually inherent in the system, the egalitarian design has to discriminate, if I may use that word, it has to discriminate more aggressively. And you can see that the periphery service gets a very good service, a very good service for the periphery, especially in the case of the Cauchy distribution. The headway is very low, okay? Now, if you go to see the corridor service, and you can see an interesting contrast between the two principles. You can see the egalitarian actually provide a worse corridor service. Okay, if you compare the headway. Okay, that means what I guess my message here is that if I present this result to a public, you cannot escape the conclusion that somehow egalitarian principle is more discriminatory. Okay, the challenge is how to explain this to the public, right? Somehow this feels more unfair. Okay. Now, so let's look at a little bit of detail. You can see that in this case, it's very clear that utilitarian design actually will worsen equity. It will have a higher Gini coefficient. Okay, so let me just go here. If you look at this case especially, in the homogeneous case, the Gini coefficient is 0.29, okay? In the utilitarian principle, after you have the heterogeneous supply, that jumps to 0.32. So in fact, applying utilitarian principle actually make it worse. This is very clear, okay, make it worse. And if you use egalitarian principle, it makes it better, also very clear. And also I want to point out, difference principle does not achieve perfect equality. There's no perfect equality. That means even though the principle is for egalitarianism, but it does not really achieve, it does not allow you to go all the way so that everybody has exactly the same outcome. So this is not equal outcome, right? It's not equal outcome. Now, this is probably the most disturbing part. If you look at here, you will say, we have heard this. This is not surprising. Of course, everybody knows that you're going to pay something in order to help the poor people. But this is 40% drop in the total accessibility, 40%, okay? 40% total drop in the total accessibility. So let me give you a sensitivity analysis to conclude our discussion of the numerical results. So I have tested sensitivity on 3 parameters. One is the budget travel time. I think this will confirm Hani's finding yesterday. So when you increase the budget travel time, of course the accessibility goes up. That's easy, but also some not very easy to say is that the Gini coefficient actually decrease. So when you have a higher budget travel time, the inequality is reduced. Okay. The second and third has to do with the mobility, right? So when you increase bus speed, when you have a higher bus speed, you also help equity, right? The inequality Gini coefficient is decreasing with bus speed. And the lost time per stop. So if you have a higher lost time per stop, you will have a lower mobility in general in your system. So, and you can see that when the lost time goes up, Gini coefficient goes up. So if you have a worse mobility, you have a worse inequality. Okay, that's what we'll observe from our data, from our numerical experiments. We did observe interesting facts here. That is to say, when you increase budget travel time, the Gini coefficient will continue to drop, but only to a certain point. After that point, Gini coefficient actually bounces back. So it seems that there's some kind of limit or bound on the equity, right? So it's really hard to get below that because of the nature of the problem. And it seems that the difference principle help you find that boundary. Anyway, so that's what we have. I want to, I think I'm good on time, so I'm gonna quickly conclude my study. We have shown that if your transit service is homogeneous, if you cannot differentiate your supply, it doesn't really matter if you use utilitarian design or egalitarian design. You have to have the ability to differentiate your supply somewhere. And we find, as you would expect, egalitarian design will have a significant equity enhancing effect, and utilitarian design will tend to exacerbate inequality. And we also find that trying to correcting this innate inherent inequality by applying the egalitarian principle sometimes, at least in our experiments, will give you more discriminatory designs. Okay, we will have to communicate that better to the public. Finally, the difference principle, it seems to help define an upper bound of equity. Continue. We found that the benefits to the most disadvantaged member could come at hefty price to society, right? I think that's for anyone who wants to promote a value, we have to face the consequence that there is going to be a price to be paid. The question is how we're going to pay for it. I think this is the cost of upholding the difference principle. This is justice, right? If we believe this is justice as a society, now this is the price we need to pay to get the justice as a fairness. Now, I want to go back to the question that I raised. I still don't know the question. I'm sure. Is it tempting to price our values a right thing to do? Is it even a good idea, right? So I'm sure there are people who are out there to say, values is priceless, right? You cannot price your values. The tendency to price everything that actually get us here, right? So we really shouldn't even think about pricing values because that's not up for pricing. But I personally think we should. I think we should. But here's why. We need to be able to assess affordability, right? So whenever we want to impose a value into our engineering systems, there's going to be a cost. We need to know whether or not we can afford it, okay? That's one thing. Second, we need to be able to communicate these results to the public so that we can rally the support. So for those reasons, I believe we should do this. We should perhaps do this more. We should just present these results to the public more, to the politicians more, right? Anyway, so there's some other ideas, some of which we're working on. Like we're trying to understand, if there's interactions between location, opportunity, and transit design, if there's some kind of, can we internalize those relationships that will make the model more interesting? Another project that Tianxin is actively working on right now is about finance, right? So if we integrate design and finance together, right? So that can help us answer questions like whether or not a fare-free transit is a good idea. You know that I heard from someone that Michelle Wu. I don't know if you know Michelle Wu. She's the progressive mayor of Boston, and she has implemented fare-free transit in Boston, right? So my question is, in that study is free fare transit just, right? Is it just per the definition of John Rawls, maybe, right? Is it just? Is it egalitarian? Meaning, does it really help the most disadvantaged member of society? Does it? I don't know if she had commissioned a research team to study it before actually put it in practice, but we're trying to answer that question. But if you want to answer that question, you have to ask where the money comes from. Is it coming from sales tax? Is it coming from fare? Is it coming from maybe some kind of user fee? You can charge drivers, for instance, can charge drivers a fee so that you can recover the cost of providing transit services. All right, so I think that's all I have. I'll stop and maybe there's questions. Hani.
Yeah, thank you, Marco. Very nice results. But I would go further, I guess, in my